Bismillahirrahmanirrahim. New syllabus 6 SSC2 unit number 10 simple harmonic motion and waves. Exercise 10 numerical problem 10.3 to 10.6. In previous video, we will discuss 10.1 and 10.2. In this lesson, we will discuss 10.3 to 10.6. In question number 3, find the time period of simple pendulum if 1 meter length placed on the earth and moon. The value of G on the surface of earth is 1/6 of the value of earth. Here, value of G is 10 meter per second square. Given data, length of simple pendulum L is equal to 1 meter and value of G on the surface of earth GE is equal to 10 meter per second square. The value of G on moon GM is equal to GE upon 6. The value of G on earth divided by 6 is equal to 10 divided by 6 is equal to 1.67 meter per second square. Required time period on the surface of earth TE and time period on the surface of moon TM. Now the formula TE is equal to 2 pi L over GE and TM is equal to 2 pi L over GM square root. Now we can find the solution. We know that on the earth TE is equal to 2 pi L over G square root. Then putting the values TE is equal to 2 pi 1 upon 10 square root. Then time period on the surface of earth TE is equal to 2 seconds. Similarly, we can find the value on moon Tm is equal to 2 pi L over G square root. Putting the values, then Tm is equal to 2 pi, value of L is 1 and value of G is 1.67 square root. Then Tm is equal to 4.9 seconds. The final result time period on the surface of earth is T is equal to 2 seconds and time period on the surface of moon Tm is equal to 4.9 seconds. Similarly, in question number 4, a simple pendulum completes two one revolution in 2 seconds. Calculate its length when G is equal to 10 meter per second square. First of all, write the given data. Time period T is equal to 2 seconds and value of G is equal to 10 meter per second square. Required length of pendulum L. Formula T is equal to 2 pi L over G square root. Now we can find the solution. Then we know that T is equal to 2 pi L over G. Taking square root on both sides, then T square is equal to 4 pi L over G. Putting the values, then L is equal to 40 divided by 4 multiplied by 9.68. Then L is equal to 1.02. Similarly, the result of length of simple pendulum L is equal to 1.02 meter. Now, in question number 5, if 100 waves pass through a point of a medium in 20 seconds, what is the frequency and time period of the wave if its wavelength is 6 centimeter? Calculate the wave speed. Now given data and number of waves is equal to 100 and time period t is equal to time taken 20 seconds. Lambda wavelength is equal to 6 centimeter. Centimeter converted into meter, then 6 divided by 100 is equal to 0.06 meter. Then required data, frequency f and time period t. Formula and speed, wave speed is equal to v. Here we calculate the three things: frequency, time period and speed. We use the formula, then f is equal to n upon t, number of waves divided by time. Similarly, we find that time period t is equal to 1 upon f and we calculate the v using the relationship v is equal to f lambda. To find the solution, now putting the values, first of all we find the frequency f, then f is equal to number of waves divided by time taken, then f is equal to 100 upon 20 is equal to 5 hertz. Similarly, we can find the time period t is equal to 1 upon f is equal to 1 upon 5 is equal to 0.2 seconds. Now we find the wave speed v is equal to f lambda. The value of f is 5 and lambda is 0.06. Then multiply 5 multiplied by 0.06 is equal to 0.3 meter per second. Result, frequency f is equal to 5 hertz and time period t is equal to 0.25 seconds and wave speed v is equal to 0.3 meter per second. Now in question number 6, a wooden bar vibrating into the water surface in a ripple tank has a frequency of 12 Hz. The resulting wave has a wavelength of 3 centimeters. What is the speed of wave? So, given data, frequency f is equal to 12 Hz, lambda wavelength is equal to 3 centimeters. Centimeter convert into meter, then divided by 100. 3 divided by 100 is equal to 0.03. Now required speed of wave v and formula we can use v is equal to f lambda. Then find the solution. We know that v is equal to f lambda. Putting the values, v is equal to frequency f is equal to 0.03 multiplied by 12. Then v is equal to 0.36 meter per second. Result, the speed of wave v is equal to 0.36 meter per second. Thank you. Next numerical in next video. Best of luck. Love.